Hey y'all, Miss Harper here for our greatest common factor notes, GCF. Alright, so we are used to seeing problems like this. We've been practicing a lot of stuff like this, and hopefully if I say to simplify this, what should we do? Well, hopefully you're thinking hippity hoppity, oops, distributive property, and we need to distribute this thing. So 6 times 2 is 12, and a times a is a squared. Alright, then I need to do it one more time, distribute my 6a to the 3, and 6 times 3 is 18, and that a will just attach on there. Now, what we're going to be going through today is doing actually the opposite of what we just did. So we're actually going to we're going to be given a statement like this, and we're going to backtrack it to a statement like this. All right, so what we call this is the greatest common factor. So if we kind of looked at this backwards, we'll see on the next slide, is we're going to see what's the largest thing I could divide away from the 12a squared and my 18a. All right, and we already know the answer because, again, our answer is up here. But we're going to just, like I said, do the exact opposite of what we just did. So here we distributed. Here we're actually going to do the opposite and factor this greatest common factor out. All right, so the greatest common factor, what is that? GCF I'm going to go ahead and pause the note video for just a second. All right, so go ahead and pause your note video if you need to and copy this down. But our greatest common factor is the largest factor that can be divided out from any given terms. And then one special note is if the leading factor, this should actually say if the leading term. If the leading term is negative, then you must factor out the negative, and we'll see some examples of that. All right, so identify the greatest common factor. So here's just a list of numbers, and we are going to just list out our GCF. So if I'm looking here, for example, at 12 and 42, we want to know what is the largest number that I can divide out from both of these numbers. All right, so if I think about the number 12 here, I have the factors of like 1 times 12, 2 times 6, and 3 times 4. All right, and then you kind of want to do the same thing with the 42. 1 times 42, 2 times 21, 3 times 14. Does 4 go in there? I don't think it does. And then we have 6 and 8 is 48. 6 times 7. All right, and so we want to see what's the greatest the greatest factor that they have in common. Well, let's see, they both have a 2 in common, so that's great. However, the 2 is not their largest common factor. We ought to find the one the biggest number we can divide out from both terms, and I see that is 6 and 6. That is the largest number that they have in common. So the GCF here would equal 6. All right, and so that is kind of how this game is going to go. So if you want to pause the video, write down these examples, and then give it a try, I am going to, after you resume the video, the answers will be posted up there for you to see. All right, so I actually decided just to do the first 3 examples there, the extra 2 examples. Hopefully you got those 2 right. Now I wanted to talk to y'all about this next one so you can see what happens whenever there's variables involved. Now here with the negative 2x and the 8y, they didn't have a variable in common. However, my leading term was negative, so I needed to make sure I took out the negative 2. Although they have a 2 in common, again, since the leading term is negative, it has to be a negative 2 that we take out. So now let's talk about this next one. So, all right, so you can think, what's the GCF between 7 and 35? 7 and 35, and hopefully you can recognize that 7 is the GCF there. Now we need to talk about the variables. So for example here, this has w to the 5th power, and this one has w to the 2nd power. So I can take away some of these guys' w's because they have some in common. What is the most w's I could take away from each of these 2 terms? Well, this one has 2, this one has 5. That means at most I can take away 2 of the w's from each of these guys. So that means our GCF in this case is 7w squared. All right, so go ahead and pause, try out the next 2 examples, and then see how you did. All right, so hopefully if you're coming back, you can check yourself and hopefully you got these two right. So here on this first one with the 12a to the 5th power, 1 is the GCF here. Sometimes 1 is that's the greatest common factor that they have together, because again, here in front of this a would be a 1. All right, so I can't divide anything out except for a 1, but they both have at least one a in common that I could take away. So again, you could write that as a or 1a. And then here on the last example, first my leading term was negative, so I needed to make sure I took out the negative. And then between these two numbers, I could take away a 5. And since he has 2 n's and he has 1 n at most, I could take away 1 n. So hopefully you got those correct. All right, so GCF, whenever it's in an expression, what we're going to do now is we're actually going to factor out our GCF. And this is what that's going to look like. So let's look at this first one. So it's kind of like back to the very first example that we did. So what is the GCF between 3x and 3y? Well, we saw that example earlier and we decided that I could take away a 3. All right, so if I divided out a 3, what would I be left with inside my parentheses? So you have a couple ways to think of this. You're literally dividing this thing out. You're dividing the 3 out. So you can think of it as division by 3, and what would you have left over? Well, 3 divided by 3 is 1x, and 3y divided by 3 is 1y. All right, now another way to think of this is if I take out a 3, 3 times what would take me back to the 3x that I had? So 3 times x, and same here with the y. 3 times what would get me back to the 3y, and that's just 1y. Okay, so again, either think of it like this way, where you're dividing out that whatever GCF, or you think about, okay, I took out my GCF, what do I need inside so that I end up back at my original? All right, so let's look at the next one. All right, first I can recognize that my leading term is negative, so I need to factor out a negative. All right, now what number do these two guys have in common? Hopefully you can recognize they have a negative 3 in common, but they have something else. What else can I take away? And that is a b. All right, now I'm more on the side of thinking, okay, negative 3b times what is going to get me back to negative 3b squared? Well, I took away his negative 3, I took away one of his b's, but he had one b left over. All right, then I think of that again, a negative 3 times what would get me to a positive 9? Well, I know that a negative times a negative will get me my positive 9, and I already took away his b. Okay, so again, if you're on the side of dividing, you could also do it this way, remembering your exponent rules. All right, and I'd be left here with b to the first power. And then 9 divided by negative 3 is a negative 3, and then my b's will cancel out. So I'm just left with the negative 3. And this is great because you can check yourself before you wreck yourself by redistributing and making sure it takes you back to your original problem. So pause the note video, try out the next 3 examples. This one's kind of hard to see down here, but this is a 3, and see how you do. All right, so here are the next 3 answers. I hope that you're able to high-five yourself right now because you got all 3 of these correct. If you have any questions about any of these, you can please come let me know. And let's go ahead and try out our next set. So one more time, I want you to pause this note video and do the same thing. Now, if you notice in this first one, you might feel like you want to take away an m. However, this term does not have that extra m. So the largest thing I can divide out is a 4. And again, with these, you should always start with your smallest number anyways, because obviously I can't factor out like an 8 or anything bigger than my smallest number. So start with your smallest number, list out his factors, and see what you have in common with your bigger numbers. All right, so the largest number that I'd be able to take away from an 8 and a 28 actually is not 4. Oops, 4 does not go 4 times 7. Oh, so just kidding. Yes, 4 works. I'm losing my mind today. All right, so I'm going to take out my 4, but I can't take out an m because my this term right here does not have an m. All right, so 4 times what would get me to 28? Well, that's 4 times 7m squared plus 2m, and then 4 times what is 4? Well, that's just a positive 1. All right. Pause the note video here, try out your next 2 examples, and see how you do. Alright, so hopefully you're able to get these ones correct. Now this first one might have been a little tricky because my leading term was a negative. So if I think about my factors of this number, it's just 1 times 3. Well, 3 does not divide nicely into 5, so my only option here is the 1. However, since my leading term is negative, I have to take out a negative 1. And then I was able to take away some exponents from these guys, so a couple of x's. And the most that they had in common was 2, or x to the second power, so I was able to factor out negative 1x squared, and then left over inside, again checking myself by redistributing. If I distributed this here and here, it's always a great way to check yourself. I would get negative 3x squared, and my negative times the negative would get me a positive 5x to the third power, taking me back to my original answer. Alright, and then same with this last one, it was a little bit trickier too. My leading term was negative, so I needed to take out a negative, starting here with the 8. Here are my factors of 8, and I'm trying to figure out which is the largest one of these. I would also divide into the rest of these numbers, and that number is 8. Alright, so I took out my negative 8 because my leading term was negative, and this 8 at the end did not have a y, so I couldn't factor out the y. So again, check yourself by redistributing this and making sure it takes you back to your original answer, negative 32y squared minus 24y, and then my negative times a negative will get me my positive 8 back, landing me at my original answer. Alright, if you have any questions, come see me.